show you guys is how I would suggest showing your work on these. So when we're going through these problems, you might have not known how to show your work before, and so I'm going to show you guys what works well just over the time that I've taught algebra. This is my 19th year teaching algebra, so it's one of those things when I tell you guys I've been teaching this longer than you've been alive, that's by quite a bit. So, and then everyone says, no, you're not that old. And then I say, of course, that's what you're supposed to say, it's okay. But yeah, so I've been teaching it for a while. So knowing what works well for students is something that I have some ideas about just because I've seen it over time. So when we work through these problems, a lot of times I'll ask myself is, what's happening to the variable? So what's happening to the x in number 1 right now before you do anything to it? What is x and 4 doing to each other? They're being multiplied. So 4 and x are being multiplied. So to undo that, what's the opposite of multiply? Divide. So we're going to change the multiply to divide instead. So I'm just going to write kind of a quick little note of that. So instead of multiplying, I'm going to switch to divide. Now, to not have to write too much stuff, because the little division symbol with the double dots, that's a little bit messy in my opinion. So what I'm going to do instead is I'm just going to make this a little fraction, which might bug you, but if I divide this by 4, I have to do that to the other side of the equal sign. So I have to divide this side by 4. So that's just quickly showing me what you're thinking. And the reason why this works so well is what's 4 divided by 4? 1. So it just cancels out there. So I kind of show that that goes away. And then if I look at that, anyone who knows math would look at that and say, oh, she's dividing negative 12 by 4. So it's a way to show what you're thinking in case you make a mistake. So let's say you gave me the answer of 2. And I'd be like, where did that answer come from? If you were negative 12 over 4 equals 2, I'd be like, oh, they just divided wrong. If you just wrote x equals 2 to begin with, I'd wonder what in the world you were up to. So I can see more of what you're thinking if you show me a little bit of work. So this is going to be a negative 3. So I'm dividing by 4 because I was multiplying by 4 before. And I know this is something you guys have seen before, but maybe the showing of your work is kind of the new part of it. And again, as we do more and more steps, I just really suggest you try to show those. This next one's a little bit confusing, because a lot of times people will say, oh, I see they're adding, so instead I should subtract. But in this case, I want to think about it as I want to isolate x. So x and negative 6 are being combined. How do I move a negative 6 over to the other side? What's the opposite of negative 6? Positive 6. So a negative 6 and a positive 6 get to cancel out. So what I'm going to do is I'm going to add 6 here, and then I'm going to add 6 on this side. So whatever I do to the one side, I have to do to the other side of the equal sign. Because negative 6 and positive 6 will cancel, and I'm getting my x alone. So then in this case, x is going to end up being 8 and 6 is 14. And then also doing like a quick check. We can always go back and see, do these answers make sense? Like going back and checking 4 times negative 3, oh yeah, that's negative 12. Negative 6 plus 14, yep, that gives me 8. So kind of working through these and thinking about those fractions or those answers if they make any sense. So the next two are fractions. I don't want you guys to encounter fractions and freak out and think you don't know what you're doing, because you do. You just showed me on this last test. Majority of you guys did really, really well in the test, or just made small mistakes. I'm not concerned about you understanding. A lot of you guys showed you know fractions. You can do them. Now in these cases, there's a very slight difference between what's happening with the 1/3 and the x. So what's 1/3 doing to x here? Multiplying. Now, if you recall, we talked about dividing fractions. But what did we do instead of dividing fractions? Do you guys remember? What did we do to a fraction? What? We multiplied by the flipped fraction. Remember, keep, change, flip? So instead of dividing by a third, we can multiply by what? 3 over 1 or just 3? So we can multiply by 3 over 1 to each side. And again, 3 works as well. 3 over 1 is just the flipped fraction. Because now what happens here is these 3's just get to cancel. So I'll just be left with x equals a negative 12 times 3, negative 36. So like really asking yourself that question over and over again, what's happening to the x? So then that takes me to our last one-step equation here. What are x and a third doing to each other? Addition. So I'm going to use either, I'm going to use addition or subtraction to get rid of it. But I want to move this 1/3 over just like we did up here. So to move the 1/3 over to the other side, what are we going to do? Take away 1/3. So we're going to take away 1/3. 1/3 minus 1/3 is no thirds. Yeah, so we need to do a little bit, of like terms, or common denominator, wrong vocabulary here. So I need to make them both 6. So we can multiply by 2. So 5, 6 minus 2, 6 is 3, 6. And then I can simplify that to be a half. And so that's the x value that's going to work in this problem. Questions there? So those are kind of the gist of the one-step problems. Now, just so you guys know, we're doing 2 sections in one today because our book kind of breaks these up in a couple of weird ways. So I'm kind of combining 2 sections to try and make it like a little more manageable, but it might be a little confusing. So I'll try to, like, it's more that the book pages are a little bit funny. So, So we're talking about 1 and 2 step equations, but only with one variable. So we're working just like an x or a y or whatever it happens to be. So when we're solving equations, you're going to hear me say the same things all the time, because you have to get in the mindset of solving equations. So I'm trying to find the x value that works for this. So in order to do that, I'm always going to say we're going to undo whatever's happening to the variable. You'll hear me ask this a lot, like what's happening to the variable? So again, guys, making sure you're taking good notes, because if I asked you, what's your first step in solving equations, you might not remember, but if you look in your notes, it should be pretty obvious. So you want to undo what's happening to the variable. Our next step, or next thing to know, little bullet point here, is when we're solving, we're going to reverse the order of operations. So solving, you almost have to think about, like, when some of you guys, maybe when you're a kid, or when I do like a home project, like if I'm replacing the faucet on our sink, and you can ask Mr. Donahue about this, he is not the handy one in our house, I'm the handy one. I've replaced the toilets in our house, and he's my muscle, that's about it. So if I take something apart at home, I go to put it back together, I have to do everything in reverse order. So sometimes I even take pictures of the steps as I'm going, so I don't miss it. So same thing with solving equations. I'm going to do reverse order of operations. So to solve, we're going to reverse the order of our operations. Because it's kind of like we're taking it apart. fill in that next bullet point, what I wrote there. It wasn't all that helpful, I don't think. So we're going to start with our steps. So the first two steps we're actually not going to use today, but I still want to write them down because they're going to come up soon. So I'm going to write these steps down, but we're not going to use them quite yet. So we're going to be kind of like wait on these. So the first thing, just like when we were doing in our test, we're going to distribute first. Now you're going to notice today there are no parentheses, or there shouldn't be many. So this step's not going to apply today, but it'll apply soon. Again, just like we did on our test, once I distribute, then I combine like terms. We probably won't have many like terms to combine. So these two steps we don't need quite yet, but that's typically what you'll do when they're more complex problems. All right, so now we're ready to do the reverse order of operations. So, we're talking about PEMDAS. I'm actually going to start with addition and subtraction and kind of work my way backwards. So we're going to add or subtract first. Subtract to isolate our x. We're going to talk about that in example 1 here. So write that step down and then we'll talk about what we need to do there. So in example 1, what's being added or subtracted to x? So example 1 up here, what's being added or subtracted to x? 12 is. So 12 is being added to x. So how do I get rid of that? How do I move it over to the other side? What's the opposite? What's that? Not 5. Yeah, we're just going to subtract the 12. So I want to get the x alone. So since it says plus 12, I'm going to subtract 12. If I do that from this side of the equal sign, I have to do it from the other. It's a balance. So whatever I do to the one side, I have to do to the other side. So please write this step down. You're going to write minus 12 minus 12. So we're taking away 12 because this says plus 12. We're going to do minus 12. And 12 minus 12 gets to cancel. So what's left on the left side?
5x.
5x. And then what do I have over here? Negative 25. It's a negative 13 and a negative 12, so it keeps getting smaller and smaller. So negative 25, and it's fine to grab a calculator for that. Don't hesitate to do that. I'm not going to look down on you if you have to quickly punch that in. So we added or subtracted to isolate x. Now we're ready to do our next step. So we've done this already, now we're ready to multiply or divide. So that's going to be my next step. So does everyone have that? We're going to multiply or divide. So same thing, multiply or divide to isolate x. So what's 5 doing to x? What's 5 doing to x? 5 and x are what? Multiplying. So to undo multiply, we're going to divide. So just like we did in the first warm-up question, now we're going to divide each of these sides by 5. Whatever I do to the one side, I have to do the other. And the 5 over 5 gets to cancel. So I'll just have an x there. So a negative 25 over 5 is going to be negative 5. So that's going to be, now we have our x alone, so we have our answer. Our last step is just to remind you guys, you can always check your answer. So step 5, I'm going to write check, or maybe sometimes you have to simplify. One of the things I do want to point out that I ask that you guys do is do write your answer as like x equals whatever it happens to be. Tell me what the value of the variable is. So don't just write negative 5 for this. I know that sounds picky, but we're finding the value of the variable. So tell me what the value of the variable is. All right? So we're going to look at examples 2 and 3. These are both very similar. But again, these first couple steps we really won't have to worry about today. So there's no parentheses here, there's no like terms, we can skip on to step 3. We're going to get into those steps in the next couple days. Not next couple days, like next week. So add or subtract to isolate x. So what do I need to do to get my x alone? What's being added or subtracted there? I see it? What do I want to move first? Yeah. Yeah, that 4 is there, and I want to move it over to the other side. But this is kind of confusing, because that negative maybe thinks that you should add 4, but the 4 is what we want to move, and the 4 is currently positive. So if I want to move it over, I'm actually going to have to subtract 4. So we're going to subtract 4 from each side. So we're subtracting 4. What am I left with on the left side now? What's that? What's on the left side?
Just the x.
What kind of x though?
Negative x.
Negative x. Be careful with that. So that negative x is there. 8 minus 4 is 4. But we're not done yet. What's still happening to the x?
It's being multiplied by 1.
It's being multiplied by what kind of 1 though?
Negative 1.
A negative 1. Very good. So it's being multiplied by the negative 1. So I still have to get rid of that. I want it to just be x equals something. So this is really like a negative 1x equals 4. Now this might be one where I would think maybe you don't have to show your work, because to me it's kind of obvious what x is at this point. However, if you're unsure, you're worried about like, do I really have this right? To get rid of that negative 1, what am I going to do? Lucas said we're multiplying, so we're going to divide by negative 1. So we're dividing by negative 1. So 4 divided by negative 1. Yep, it's a negative 4. And now you might have gotten 4 for this answer, but if you go and check 4 as your answer, 4 minus 4 is 0. 4 minus 4 is not 8. So when it's a negative 4, it works. And again, positive versus negative is so important. Again, think about your bank account, or think about either getting money from parents or owing money to your parents. It's a big difference. All right, we'll do another one, and then I am going to throw a few fraction problems at you. So, and then we'll stop to do a little activity for a little different type of work here. All right, so example 3. Again, go to the add or subtract first. What am I adding or subtracting? Get rid of that negative 6. So what are we going to do instead? Yeah, so that 6 is like the addition and subtraction. So since it's negative, we're going to add 6. Because a negative 6 and a positive 6 gets to cancel. So on the left side, I'm left with a negative 2x. And what's on the right now? 14. So once I get to this point, now I have to get my x alone. Not add. What's negative 2 doing to x? So So we're gonna divide by -2. So yeah, kind of asking yourself that question is what's happening? I know that seems like, I mean, just one extra thing to do, but it gets you to realize what you need, the math you need to do. So 14 divided by -2 is a -7. And so again, the positive versus negative is a big deal. All right, we're gonna flip to the back side. However, I'm actually gonna change one of the questions. So if you guys could flip to the back side, I want to do, bless you, go away. I want to do example 6, but I changed example 6. So if somewhere in the margin or underneath example 6, you want to cross it off and write this instead. So I want to do this problem, example 6, but I want to get rid of the old example 6. Sorry. I want to show you guys this one here. So you guys have changed example 6 to this problem. So we go to example 6 here. This one here. So, add or subtract first. What am I adding or subtracting? Where it says subtract 5, so instead we're going to add 5. So we're adding 5. So 7 plus 5 is going to be 12. All right. So now I want to get rid of that 3/4. There's a couple of different ways to go about this. Anyone have a guess or an attempt on what they want to try to do? Make sure we write our problem. So 3/4 x minus 5 equals 7. Anyone have, like, just take a, I mean, there's a couple of different ways you can go about it, yeah. Yeah, it's being multiplied, so we're going to divide by 3/4. And if you use your calculator, it'll allow you to divide by 3/4. But what's the same thing as dividing by 3/4? Because we don't technically divide by fractions. Not negative. Remember, keep, change, flip. So what do? We're going to multiply by 4/3. So this is one way to do this. So Tori's right. You're going to really divide by 3/4. But technically, if we want to do this by hand, we don't really divide by fractions. Instead, we multiply by the flipped fraction. Now, you won't get the wrong answer. I'm just trying to show you guys why this works this way. Like, you might look at your calculator's answer and be like, I have no idea how you got that. And this is kind of the why behind it. So this becomes 12 times 4 is 48 over 3. And 48 over 3 is 16. That's one way to get the answer. Again, if you divided 12 by 3/4 in your calculator, it should have gave you 12. Did anyone try it in their calculator? Did that work for you? Did anyone have any other way to do it? I might just show you guys one other way here, just in case that doesn't seem obvious to you. So if you're at this point, this is just another way. Again, I don't show a ton of different ways to do things, but this is one that I definitely have enough students that pick it up and like it. So they see it looks like it's dividing by 4, so instead they multiply by 4, so they kind of turn this into 2 steps. So we're left with 3x over here equals 48. So kind of just breaks this into 2 steps rather than working with so many fractions. So we do end up getting x is 16. It's just kind of takes a little bit more time, or maybe that's more obvious, or maybe you want to just stick with what you have. So trying to show you guys different ways sometimes if it might be something that makes it a little bit easier for you. So what we're going to do now is we're going to do this little math puzzle, but you're welcome to work with other classmates on this or work on your own. What I would tell you guys though is you should probably divide up the work. So like if you're working with like a few other people, maybe that you each take like a column Or if you guys are working on your own, I might assign you a column, kind of assign you one that somebody else doesn't have, because we need to make sure we get through all of them. You don't have to do all 16 questions, but so the way it works is based off your answer, then you put the letter of that answer up by that number. So you're gonna work on this with your, like if you wanna move around, sit with some other people to work, give you guys a chance to talk a little bit, help each other. Again, you probably won't finish the whole worksheet on your own, but maybe if you break up the work, you should be able to kind of jigsaw it a little bit. Haley, I'll send yours back with these guys. So feel free to move to go work with somebody. So we'll see you guys online. I'll stop the video for